So now we'll turn our focus to what neurotransmitters are involved in processing pain perception. So up here you'll notice that we have glutamate, GABA, opioid receptors. Something we haven't heard of before is substance P, and then we also have norepinephrine and serotonin. So there's actually a lot of different signaling that happens. So when you think about developing a drug to interfere with this signaling, you have kind of a lot of options. And part of it depends on what type of pain it is and what you're going to choose to modify it, and the specific neurotransmitters you're able to modulate in that signaling. So first, what we're going to look at is the pain pathway. And what you'll notice is that you have different neurons here, and they are conveniently color-coded. And hopefully what you can see is that you have kind of two different pathways. So you have this coming in and then providing input here, and then this is continuing to go, information continuing up the spinal cord to the brain. And then you also have another pathway but coming down in the opposite direction. So just to orient you, the circles are the cell bodies. This one happens to be a cell in the dorsal root ganglion. So these are the sensory peripheral fibers. And what they have, the cell body is here, and then the information is coming in from the periphery, coming into here, and then synapsing in the spinal cord. And so then this is the second cell body that's then sending its information up to the brain. And now you have another cell body located here that's sending its information back down. So you have this kind of feedback loop. And I'm going to give you the wording for this to write down as well. And we'll start with what we call this primary afferent. So this is information coming in from the body. So let's say that this is at your finger, and you pricked your finger, and now that information is coming in. Those nociceptors are active, and then the information is coming in, and then that's synapsing here, and then sending the information up. So this primary afferent is a sensory neuron from a body part, and that starts what I call the ouchie signal. And the neurotransmitters that are located there or that are released here are glutamate and substance P. And so these are excitatory neurotransmitters. So that information comes in, and now it's activating the information in the spinal cord. It's because you need to do something about it. And that information is activating what we call this second order neuron that's going to send the information to the brain. So that second order neuron takes the ouchie signal to the brain, and then you feel the pain. So your pain perception is increased. You are notified that you did something to hurt yourself. But when you look at that second order neuron is also activating this blue neuron in the descending pathway that's going to feed back to that spinal cord. And that blue neuron, or that descending neuron, is going to help you manage that pain. It's like, okay, we got the signal, that doesn't feel nice, so you can stop. And what that does, activation of that one, decreases pain perception. And that is through serotonin, norepinephrine, and the opiates, which are acting here inhibitory. So glutamate and substance P activating this one, that loop going up to the brain, but then coming back down and saying, okay, we got the message. Those neurotransmitters that are released from this blue neuron are serotonin, norepinephrine, and opiates. And you can also see that here. So this purple one coming down you have glutamate, which is excitatory, and substance P, which is also excitatory, to excite that second order neuron. Then you see that blue one coming down, that descending neuron, which is releasing serotonin, norepinephrine, and opiates. And what it's doing, it's inhibiting that second order neuron to say, hey, stop responding to that information. And then it's also inhibiting the primary afferent to say, hey, stop sending that information. And in addition to that full descending neuron, you have this little tiny inhibitory interneuron, which is it's much smaller, right? So these are really long neurons. They're going from your arm to your spinal cord. They're going from, in this case, like your spinal cord level at your torso and moving all the way up to your brain and then coming from your brain back down to the same place. So these three are really long neurons, but this one is just a short little inhibitory interneuron. And what it is also able to do is inhibit this second order neuron here. And it's doing that by releasing GABA to inhibit here, glycine to inhibit here, and opiates really to inhibit both here and here. So it's like mainly preventing the release from that primary afferent neuron. So two ways to inhibit that pain signal already built in naturally for us. And again, down here in words, so that inhibitory interneuron is going to modulate the signaling, leading to decreased pain perception. So this modulates that signaling locally, whereas this blue one came from location in the brain. This inhibitory interneuron is just right there to decrease that pain perception locally. So this is how natural pain processing happens. And as you can see, we have natural ways to inhibit the pain processing when there is that damage in the periphery. So then the next thing is to think about, well, how can we manipulate this pharmacologically in order to increase the pain inhibition?